So, have you ever written a piece of code? I mean, you were really proud of it, only to look back a year later and realize well, it's basically a fossil? In a world where it feels like a new framework drops every 6 months, that's the real challenge we're going to tackle today. How do we actually build software that lasts? Seriously, stop letting your code become obsolete before it even ships. Look, the biggest threat to your software, it's not some bug you missed. It's that relentless, nonstop wave of technological change. And this isn't about some quick fix or a new library. Our mission here is to hand you a whole new playbook for development, one that helps you build software that is actually built to last. All right, here's how we're going to break it down. First up, we'll dive into what I'm calling the looming code decay. Then we'll talk about architecting resilient foundations. After that, we'll get into how to anticipate future tech shifts. We'll cover the modern longevity toolkit you need. And finally, and this is a big one, we'll look beyond the code to the human element. Let's get into it. Okay, first up, the looming code decay. And the subtitle here is Key: Why Your Software is Already Dying. So yeah, let's just rip the Band-Aid off and start with the problem. We're calling it code decay. It's like this natural entropy for software, but honestly, it's happening faster than ever before. I mean, think about it. Code decay is this natural breakdown of software, but it's being supercharged by the relentless march of tech like AI and quantum computing. A few years ago, AI was this niche, specialized thing, right? Today, if your app doesn't have at least a plan for AI, you're already playing catch-up. We're even starting to see the early ripples of quantum computing hitting cryptography. It just goes to show the whole set it and forget it mindset, it's officially dead. And listen, this is not a new problem. Welcome to the tech graveyard. We have all seen this movie before. Remember Adobe Flash? For a solid decade, Flash was the interactive web. It was everywhere. But it was proprietary, riddled with security holes, and useless on mobile. So when the world shifted to open standards, entire companies built on Flash either had to rebuild from the ground up or just die. And then there's AngularJS, a fantastic framework until Angular 2 showed up as a complete rewrite with no easy migration path. It left so many projects completely stranded. And that gets us to the real cost. And believe me, it's not just about the money. It's about the operational drag, that constant friction just to keep the lights on. It's about trying to attract top talent. And who wants to work on a 10-year-old ball of spaghetti code? Nobody. It's that feeling of dread you get when you know fixing one tiny bug is probably going to create 3 new ones. Your code literally becomes a prison. It traps you, and it kills your ability to innovate. So, how do we fight back? We stop building our house on sand. We start with architecting resilient foundations. It's about building a house that's meant to last. Let's dig into the architectural principles that actually make this happen. And this right here perfectly shows the core idea: separation of concerns. Just look at the difference. On the left, you've got the fragile monolith. Your user login logic is all tangled up with your payment processing. So what happens? You can't upgrade your payment gateway without praying you don't break the login page. But on the right, you have resilient modularity. Each piece has one job, they're independent, and they talk to each other through clean, stable interfaces. That is what resilience looks like. Okay, this brings us to your absolute superpower: abstraction. Let's make this super practical. Imagine you need to store files in your app. The easy, tempting thing to do is just write Amazon S3 code right into your business logic. But please don't do it. Instead, you're going to define a generic interface. Let's call it iFile storage. Then you write a specific implementation, say S3 storage, that uses that interface. So why go through all that trouble? Because in 5 years, when some amazing new file service comes out that's way faster and cheaper, all you do is write a new class for it. You swap it out in one line of config and you're done. You have just future-proofed your entire application from your vendor. And all of this leads to this amazing concept of anti-fragile systems. Nassim Nicholas Taleb came up with it. These are systems that don't just survive chaos and stress, they actually get stronger from it. Think of it like a muscle, right? If you never stress it, it gets weak. But if you stress it, let it recover and adapt, it grows stronger. The most famous example of this in tech has to be Netflix's Chaos Monkey. It's a tool that intentionally and randomly shuts down their own production servers. Sounds insane, right? But it forced their engineers to build a system that just expects failure as a normal, everyday thing. Now that is building for true resilience. All right, so a good architecture is defensive. That's a great start. But a great architecture, it's also predictive. We're talking about anticipating future tech shifts. And no, you don't need a crystal ball, you just need to learn how to read the weather. And the number one rule here is to follow the standards, not the hype. Look, new JavaScript frameworks are cool and exciting, but the real lasting power is in the ECMA standard itself. That's where the language evolves. Code that you build on established, open standards from bodies like the W3C for the web or the CNCF for cloud-native stuff, that code will always outlive code that's tied to one company's proprietary magic bullet. And this is a huge one. This quote says it all. If you build your entire system around a proprietary feature of a single cloud provider, you are now a customer for life. Think about that. You should absolutely use the power of the cloud, but you have to be so careful about vendor lock-in. The moment you build your whole system around some super specific magical feature from AWS or Google Cloud, you're trapped. They could triple their prices tomorrow, and what are you going to do? Pay up or spend the next 2 years re-architecting everything? You've just given away your freedom. And this is where something like a microservices architecture can be a massive win for longevity. What it means is you can take one piece of your system, say the search service, and completely rewrite it in a brand new language to get a huge performance boost. And your user profile service? It doesn't even know or care. You get to evolve your system one piece at a time, which helps you avoid that dreaded, terrifying, big bang rewrite. Okay, so if the architecture is the skeleton of your application, what we're about to talk about, this is the muscles and the immune system. These are the things that keep your code healthy day in and day out. This is your modern longevity toolkit. First thing in the toolkit, and I mean this is absolutely non-negotiable, your CI/CD pipeline and automated testing. Think of your test suite as the silent guardian of your code's future. It is the only thing that's going to give a brand new developer 5 years down the road the confidence they need to refactor a critical piece of your system without being absolutely terrified of breaking everything. Next up, documentation. But I'm talking about documentation that people actually use. So forget that 300-page Word doc that's outdated the second you hit save. Good, living documentation starts with the code itself, self-documenting variable names, for example. It's the README file right there in the code that explains the why behind your decisions. And it's API docs that are auto-generated from the code itself because that way they can never, ever lie or fall out of date. All right, and let's talk about the elephant in the room, technical debt. We usually see it as this evil monster we have to avoid at all costs. But a much healthier way to think about it is as a deliberate, strategic loan. Look, sometimes you have to take a shortcut, a quick and dirty solution, to hit a critical deadline. That's business. But just like any loan, it accrues interest, and you absolutely must have a repayment plan. The moment you decide to take on that debt, you should also be creating the ticket in your system to fix it later, and ideally scheduling the time to actually pay it back. So we've covered architecture, we've covered tools, we've covered strategy. But you know what? None of it, and I mean none of it, matters without the single most critical and honestly most overlooked component of all, the human element. Because longevity is a reflection of culture. The long-term health of your code is a direct mirror of your team's culture. It's that simple. For managers out there, this means you've got to invest in training, send your people to conferences, and create what's called psychological safety, where it's okay to experiment and fail. And for all you developers, it means you have to stay curious, be a learn-it-all, not a know-it-all, own your professional growth, and have the courage to challenge that we've always done it this way mindset. Because when you boil it all down, this is probably the most important thing to remember. Future-proofing isn't a task you complete. It's not a framework you install. It's a mindset. It is a continuous, ongoing process of building for change, of expecting the unexpected and writing code that serves not just the immediate need, but its own future. So, what does this all boil down to? It's about elevating our thinking. It is so easy to get completely caught up in the next feature, the next ticket, the next deadline, but the true craft of software engineering is building something that is not just valuable, but also durable. So let's stop writing code for next week. Let's start architecting for the next decade. And so I'm going to leave you with this challenge. I want you to take a hard, honest look at the project you're working on right now. What's one part of your code you can make more resilient today? Where are you locked into a vendor? Where's your test coverage the weakest? What is one single thing you can do starting this week to make your code just a little bit more ready for the future? Think about it.